All right, we're in the garage today. We're going to take a look at pressure washer hoses and some of the things that are different about different pressure washer hoses and how they affect your pressure washer. And we're going to get into some topics about pressure as well, and some, and a bit about flow rates and how the pressure washer deals with those things and the effects of changing, the diameter of your pressure washer hose. So, yeah, let's get into it. All right, so we have a few hoses right here in front of us. We'll go from left to right, and yeah, this is basically your typical pressure washer hose that comes with almost every pressure washer. They're usually about 15 to 20 feet long, and almost always have these sort of connectors on there. These are called M22 by 14 millimeter connectors. And if you already don't know what that stands for, the thread, I don't know if you can see it, but there is a thread on the inside here that is an M22 thread or 22 millimeter thread. And the 14 refers to the post here being a diameter of 14 millimeters. So um, these do come in a couple different flavors depending on what market you're in. I think there's an M22 by 15 out there. So, just pay attention to what fitting is on here. But most of the time, they'll be M22 by 14. So this is a 1/4 inch hose. 1/4 inch refers to the inside diameter of the hose from one side to the other. So your opening on the inside has a diameter of 0.25 inches. This next hose that I have here, this is an Uberflex hose. And what I've done here is this used to have the M22 by 14. It still does. But what you can do is get quick connect fittings and just screw them on there, right? They're very easy to put on. All you do is you take your fitting. Sometimes you got to press it in just a little bit to get past the O-ring. But once you're past there, they screw on very easily. And you just get it till it's hand tight. I typically will take a wrench and give it one little grunt and make sure that it's on there and not going to fly off on me. For material, a lot of these come in brass or stainless. It really doesn't matter. Brass would be more susceptible to some corrosion. I do have some corrosion happening on here. Some of it is from water, and I think some of it might actually be like a galvanic corrosion of some sort. It's not the same color on both sides. One side it's corroding red, the other side there is white corrosion. So that's actually two different types of corrosion. But normally, if you're using like materials, so if you put a stainless fitting onto a stainless hose end, you're not going to have any issues. So just try to get your materials to match. That's the best way to avoid corrosion. Yeah, a lot of Uberflexes, they are known for their flexibility, right? That's why a lot of people use them. It helps when you're walking around the car. But in this case, Uberflex hoses, they don't have a steel braid in them. That's part of what makes them so flexible. So as these heat up, say on a hot day, and you're outside, they tend to stretch a bit. They both stretch in the diameter and they also stretch in length, right? And that can cause some issues with your pressure washer to surge. So but some pressure washers have the issue, some don't. I think it was more common on the actives. I didn't have any major issues. It just sounded kind of weird when it would fill up at times. So um, yeah, I don't use this too often, but some people do like them. So that's the Uberflex, and then over here I have my 3/8 inch hose. So this is a 50-foot 1/4 inch hose. This is a 100-foot 3/8 inch hose. So our end-to-end length on this one is 50 foot. We're 100 foot on this one. Now the difference between a 3/8 inch and a 1/4 inch, it might be kind of hard to see on camera, but you do gain a little bit more diameter. And what that helps with is the amount of pressure that is in the hose. So, and what I mean by that, I guess we can call it flow resistance. I've mentioned this a couple times. Um, we need to start looking at pressure as a resistance to flow, not necessarily how hard something comes out of the nozzle. So I've stated earlier, a high pressure does not necessarily mean more cleaning power, right? So let's erase that from our minds for a moment. Um, our pressure washers deliver flow. That's their job. And they do what they can to deliver the same amount of flow rate. So we'll get into that in a moment, but I just want to just highlight the differences of some of these hoses. You can see on the end here, I've got stainless steel fittings, and then we have a pressure gauge for something we're about to do, and I'll show you. So yeah, that's hoses. That's as basic as it gets. You're looking at diameter, length, and fittings, and that's really all you're looking at. So it obviously wouldn't be a Steve video if we didn't get into some numbers. And the first question that I want to look at is, does diameter matter, right? The diameter of your hose, does it matter? Does it matter if it's a 1/4 inch? Does it matter if it's 3/8? I think the other one is 5/16 now that Active's put out. So we have a few options, but does it matter? And the answer to that question is, well, I think that's kind of the wrong question to be asking. What we should be looking at is, how does hose diameter affect our pressure washing system, right? And there is a difference. It does change how the pressure washing system works and how it performs. But to go all the way back to the beginning of diameter, how does diameter relate into the system, right? And we know that diameter is the distance from, if you look at the inside of your hose and drew a line across, that's your diameter. That's your inner diameter. What we have on the outside here are just some, your inner wall and your outer wall. So this is just a slice of the hose, and that is diameter. Your area is the space that this slice of hose creates. So if we look at the space here, this void, open space, is known as your area. So think of area as like square footage to a house, right? That's how you measure the open space, right? And when we talk about square inches, it's really how many, literally how many square inch boxes can we fit inside our hose. Now, the reason that's important is because area is almost 1-for-1 related to flow rate, right? Diameter and area have an exponential relationship. So what that means is, if your diameter, for example, and I'm going to make up some numbers, I just want to highlight exponents and what an exponential relationship looks like. If we have a diameter of 2, that would mean our area could be 4, right? If we have a diameter, let's double it, right? We'll double this. If we have a diameter of 4, well, our area goes to 16, right? So if we went to, let's just go by 2s here, right? If we went to 6, area goes to 36, and so forth. That's what an exponential relationship means. If you really want to get into the technicality of it and want to calculate area for yourself, you can use this formula. Area is equal to pi over 4 times your diameter squared. So you can come up with your area on your own that way. I'll go over a couple numbers real quick, but the important thing here is just to recognize that there's an exponential relationship between diameter and area. So as your diameter increases a little bit, your area increases a lot of bit, okay? I actually went ahead also and calculated this stuff. So if you look at a 1/4 inch hose, the area is equal to 0.049 square inches. And for a 3/8 hose, now, in case you don't know, 1/4 inch, 1/4 is 0.25, 3/8, 3/8 is 0.375. So when you calculate area, I go to decimal points, right? So for 3/8 inch hose, we have an area of equal to 0.110 inches square inches, right? So right away, we can actually see this exponential relationship, right? Our diameter has increased by 1.5x, but our area has gone up by 2.2x, right? So this concept also applies to your nozzles. And your nozzles, as we already know, can have a huge effect on pressure, right? There is not a the relationship between flow rate, pressure, and diameter is not 1-to-1. If you double your diameter, as we just saw, it does not double your area. It actually can quadruple it. It's an exponential thing. So keep that in mind when we go from, especially on real small scales where you have a higher percentage of change. A small nozzle going up to another size is actually quite a large deal. So, but let's stick to hoses for now. So that's our area. How does it matter? Why does it matter? Let's take a look. Okay, so let's get into the meat and potatoes of what it actually does, right? How does it affect your pressure and your flow rate? The first thing I want to point out is we're going to stop thinking about pressure as a force, an outward force for a moment. We want to think of pressure as a resistance to flow, right? Our pressure washers are what's called a constant flow device or constant flow pump, and they are a positive displacement pump. So what that means is that pressure washer behind me will do whatever it can to deliver the rated flow rate. So when we change the nozzle sizes on our guns, you'll notice that the flow rate doesn't actually change significantly. You get some change, but it's not a huge amount. You see more fluctuations in the pressure, and that's because this is designed to flow a certain amount. So if we were to look at a 50-foot hose, we're going to assume 50-foot hose at 2 GPM, right? All the scenarios I'm about to do are with a 50-foot hose at 2 gallons per minute. The reason those numbers are being used is those are pretty common numbers for pressure washers, but also at this point, we need to start thinking about pressure as a resistance to flow, right? When we flow, right, so if we have a hose, right, and we put a pressure gauge on this side and on this side, and we're flowing this way, no matter what happens, this pressure gauge will always read higher than the one at the end of the hose, right? Again, we're used to thinking of pressure as the outward force of your fluid against your hose walls. That's true, that still stays the same, but it is also a resistance to flow. And that resistance to flow can be seen as what is known as pressure drop. So pressure drop means, right, if this gauge is reading, I'll make up some numbers, 50 PSI, and this gauge is reading 100, well, your pressure drop is, if you can already guess, your pressure drop is 50 PSI, right? So 100 minus 50, your delta P in the middle is your differential pressure or your pressure drop. So your differential pressure is 50 PSI, right? That is a physical thing that happens in every single hose. If that does not happen, well, then you have some sort of physical anomaly, right? Because there is always friction, there's always viscosity. Without those things, if they didn't exist, then the pressure would be the same. But those things always exist, so you will always see a pressure drop, right? So what does pressure drop look like for a 1/4-inch hose and a 3/8 hose that is 50 foot long, right? So this is a theoretical number. I calculated this using actually I used a hydraulic hose calculator from a vendor that makes hydraulic hoses. I figured they would know what's up. The numbers are probably a little conservative, that's typical. So that means we're going to end up calculating a higher pressure drop than what we might see in real life, but that's just part of design and how you design a hose system. So for a 1/4-inch hose that is 50 foot long at 2 gallons per minute, you could see a pressure drop, and this is for just a straight hose, of 91 PSI. For a 3/8 hose in the same scenario, you could see a pressure drop of 11.8 PSI. Well, that's not huge, right? That's not, I mean, 90 PSI you're losing to your hose on a 1/4-inch. And when you're putting out, you know, if your system pressure is up near 800, 900, 1,000 PSI, that's not really a huge amount. So does it matter? Well, what does this mean though? What does that 91 PSI mean, right? And if we remember from my previous video, we talked about cleaning units and how cleaning units is actually the power required to overcome your resistance to flow, your pressure. So we can actually look at this PSI and convert that to power, right? And when you go through it, and again, theoretical, there could be some variances to these numbers, but it at least gives us some sort of baseline to look at. When you look at a 91 PSI resistance to flow, that is worth 0.68 amps. And then when you look at the 3/8 hose at 11.8 PSI pressure drop or pressure differential, that is worth 0.06 amps. So same length hose, same flow rate, different diameters, different levels of amperage are required to overcome this pressure drop. So what does that mean? That means at 50 foot, if you're right at that 15 amp limit and you are totally committed to the nozzle that you have in. So what does that mean for us? Well, that 0.68 amps is the amount of power it takes to push water through your 1/4-inch hose. So if you're sitting at 15 amps and for whatever weird reason, you are so committed to not changing the nozzle on your pressure washer gun, the only way to come down underneath that 15 amp limit is to either shorten your hose or go up to a 3/8 inch hose to drop it down by, 0.6, 0.7 amps, right? And something to keep in mind here, the relationship with length and power usage and resistance to flow, it's linear. If you double your length, all of your other numbers double, right? So that's all that hoses do though. That is the only contribution to the system. So I did set up a little experiment. I've got 2 pressure gauges. I've got one right at the outlet of the pressure washer, and I have another one here. It's kind of hard to see, but it's right at the gun, right? And what we'll do is we'll take a look at the pressure drop through the 3/8 inch hose and the pressure drop through the 1/4 inch hose. Now, something to keep in mind, a 3/8 inch hose has very little pressure drop, so that means we might not even be able to see it on the pressure gauge. A 1/4 inch hose, we might be able to see it. Typically, pressure drop is measured in inches of water, which is a much smaller unit than PSI. It makes things a lot more visible. So keep that in mind when we take a look at the numbers. Okay, so we have our little setup here. We've got gauge A right at the outlet of our pressure washer. And then we have gauge B right at the end of the hose. So we should be able to see the pressure drop from the outlet through the interconnecting hose, through the spool, and read the pressure up over here, right? So I've got a little bucket, and I'll do my best to take a stable video, but let's see what we come up with. All right, so on the 3/8 hose at 100 foot, saw basically the same number on both, so let's put it down around 750 psi, right, on both of them. Again, because it's such a small, you can see that I can't see 10 psi on here. It's impossible. I can only see up to 100. So with these pressure gauges, I'm not seeing really any tangible difference between the two. All right, so now what we're gonna do is we're going to switch out the hoses. We're gonna go to the 1/4 inch 50-foot hose and take out the 3/8 hose. So, and we'll see what the difference is there. Always depressurize before you take off the hoses. I almost just messed that up. Would not have been the first time though. We're getting rid of all the air bubbles that are in there so as to not mess up our pressure readings. Not hearing any air bubbles. Let's see what pressures look like. All right, test number 2 with the 1/4 inch hose. All right, so hopefully you saw the same thing that I did, but down at the pressure washer, we had a PSI around 800, and down at the gun, 750. So for this one we had 0 pressure drop, and this one we had 50 PSI pressure drop. So yeah, hose length does change the performance of things. Something to keep in mind, if we were to put our hose and a gauge here and a gauge here, and we draw in our little pressure washer gun, right? This gauge, again, pressure is a measurement of flow resistance. This gauge is only going to measure the resistance down here. This gauge will always read a higher pressure because it is measuring the total resistance of the entire line. So all of this added together is what that pressure is. So in a constant flow pump that tries to flow the same flow rate, there's only single combinations that can happen on this end of your hose that you can have a specific flow rate and a specific pressure. So if we don't change the nozzle and we have the same flow or the same flow rate, this pressure will always read the same. Up here, if we have the same flow and the same flow rate down here, but we change the size of our hose, we will see differences in pressure upstream. You're always reading your downstream pressure. So, you know, a lot of tests and a lot of reviewers tend to put the pressure gauge here and they say that nothing changes upstream, nothing changes your pressure. Well, yeah, that's right, because it's only measuring from here to the end of the gun. So, yeah, so it's most, not a huge deal, small error in how we present things, but yes, your pressure upstream will change because this pump is always trying to flow, we'll call it 2 gallons a minute, always. And if there is a restriction downstream, like a thinner hose, this will use more amperage to get to the RPM necessary for 2 gallons a minute. So hopefully that makes sense. Leave your comments in the description, or I'm sorry, leave your comments below if you have questions about this. But I think we can conclude here that, yeah, hose diameter and hose length does matter. How much it matters depends on your individual system. And honestly, if you're sitting at, again, right at that 15 amp limit and you need to come down a little bit, the best way to do it is actually just to change your nozzle, right? Stepping down or stepping up to a larger nozzle just by one step can alter your PSI by, 200-300 PSI. And we're only talking about 0.003 of an inch on the 2 or 0.003 of an inch on the end of a nozzle. So this will have much greater impact on your overall system pressure. But if you're really running those limits, you know, go to, change your hose setup. It's not going to make a huge difference, but it will make a difference. And, especially for if you need to run a long hose, don't run a 1/4 inch hose if you're going to be running a long hose. The longer your hose, the more friction your pressure washer has to overcome. So use a 3/8 inch hose or a larger diameter hose. But for short run hoses, say we'll call it 50 feet and under, most pressure washers are going to be able to compensate for the smaller diameter. So leave your questions below. I hope you learned something. I know I did. I love doing this stuff and talking about it. So I'll see you guys on the next one. I think our next video is going to tackle panel impact ratio. That's a little bit easier one to tackle, but still it's confusing, and not a lot of people fully understand what it is that they're calculating. So we'll get into that, and yeah, I'll see you guys in the next one. Take care.